All right, so here we are, Geometry Kids. We are going to talk about Chapter 3. We're going to look at angles and parallel lines. And so I hope that the vocabulary from Section 3.1 made sense because 3.2 is going to utilize a lot of that information. So the first thing we got, let me make the screen a little bit bigger for us. So we've got these postulates that we got to keep in mind. And remember, postulates are things that we're going to accept as true and not necessarily prove. So the first postulate is 3.1. It's about corresponding angles. Notice when you have, so a lot of these postulates we talk about today are going to be if you got two lines that are cut by a transversal. Not just any two lines, but two parallel lines. So all of this is about some neat things that happen when parallel lines are cut by a transversal. So if we've got two parallel lines, as we see here, these little arrows indicate parallelity. That's not a word, but you get what I mean. The parallelness, the state of being parallel. If you got two parallel lines cut by a transversal, then here's what happens. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4, and then angle 6 is congruent to angle 8, and then this angle 7 is congruent to angle 5. You get the picture here. So basically it says corresponding angles are congruent. Parallel lines cut by a transversal, corresponding angles are congruent. So let's go ahead and use that information to help us out with example 1. In this figure, the measurement of angle 5 is 72 degrees. Find the measure of each angle and tell which postulate or theorems you use. Well, since they ask us about angle 4, angle 4 has to be the same as angle 5, and the reason why is because we just learned if we've got two lines that are parallel, as we have here, that are cut by a transversal, corresponding angles are congruent. So instead of calling this like postulate 3.1, because I'm not going to remember that later on, I literally write it out, but I write it out in an abbreviated style. So I'd write parallel lines, cut, parallel, that's the symbol, looks like an 11, but two long lines, parallel lines cut by transversal corresponding, and I'll put like this, little implies that the corresponding angles are congruent, and that's where we got that from. And the next thing they ask us about is angle 2. What's going on with angle 2? What's the measure? Well, hopefully you know that angle 2 also has to be 72 degrees, just as this guy was 72 degrees. And the reason for that, so do you remember we talked about vertical angles being congruent? And because vertical angles are congruent, we can say that angle 2 is congruent to angle 4. Knowing that angle 4 is equal to 72 degrees, we can therefore say that that's 72 degrees. So I'm just going to put vertical angles are congruent. And I'd probably do like this, are congruent, and not write out the word angle. So let me erase this. Now your text has like a mini proof written for each of these. I'm not really into it. If you ask me to find the measure of angles and tell which postulates and theorems you use, to me this is sufficient. So I'm coolio patchoulio with that. Let's go ahead and take a look at a couple other bits of information. So from that postulate, we can gain this other information. We can tell that alternate interior angles have a certain relationship, consecutive interior angles have a certain relationship, and alternate exterior angles have a certain relationship. And I want you to just take a look. Remember, corresponding angles were congruent, alternate interior angles are congruent, alternate exterior angles are congruent. You know what's not congruent? Consecutive interior angles. Those guys are supplementary, and I want to point that out. So I just want to go through it really quickly. Remember when we had corresponding angles, I'm just writing it here, those guys were congruent. Remember, parallel lines cut by a transversal, corresponding angles are congruent. Alternate interior angles rather, cut by a transversal, created by a transversal cutting parallel lines, those are congruent. Alternate exterior angles, so these were interior alternate exterior angles, are going to be congruent again. The only thing that's not congruent is this guy. Consecutive interior angles, those are going to be supplementary. So angle 1 and angle 2, those are consecutive interior angles. Those are supplementary. They add up to 180. Same thing with angle 4 here and angle 3 over here. Okay, so that's what you need to get from all of this. You can take your time and read through this at your own leisure, but that's ultimately what every one of these are basically telling us. So if we take a look at this real world example, number 2, community planning, Reading Lake and Creek Road are parallel streets, boom, boom, and that intersect Park Road along the west side of Wendell Park, and there's Wendell Park. If the measurement of angle 1 is 118 degrees, that's this guy here, what is the measurement of angle 2? So I'm going to put the 118 right here. What is the measurement of angle 2? If this is 118, what's this guy? And hopefully you remember, well, let's name these two angles. These angles are interior, they're alternate, so these are alternate interior angles. From our information above, we knew that alternate interior, alternate exterior, and on the last section, corresponding angles, when they're created with parallel lines cut by a transversal, those are congruent. So that tells me that these guys must be congruent too. So the measure of angle 2 must equal 118 degrees. Here in example 3, we're going to find values of variables, and we're going to do that using some of the information that we've been talking about. Again, we've got parallel lines here cut by a transversal, so we know that there's a lot of equality going on here and some supplementariness. So use the figure of the right to find the indicated variable and explain your reasoning. Well, I see that the measure of angle 4, that's this guy here, is 2x minus 17, and the measure of angle 1 right here is 85. I am supposed to find the measure of angle x. Well, if this is 85, then over here, this has to be 85 as well. Do you know why? I hope you recognize that these are vertical angles. So these vertical angles are both 85 degrees, right? And then I'm looking at what I have, and I see this transversal, and I see these two angles on the transversal, and I remember that these are called not corresponding angles, but consecutive interior angles. And there's something about consecutive interior angles we should remember. Consecutive interior angles are the only angles that are created, right? The only pair of angles that we've talked about that are created by two parallel lines cut by a transversal that are not congruent. Consecutive interior angles are supplementary. What that tells me is that the measure of angle 3 plus the measure of angle 4 must equal 180 degrees, right? Angle 3 and angle 4, consecutive interior angles. They're supplementary. Their measures add up to 180. Therefore, this angle being 85 degrees and this angle being 2x minus 17 degrees is equal to, tells me that the sum of those two values will be 180. So when I simplify this, 85 plus minus 17 is going to end up giving me 68 plus 2x on this side, right? So I'm joining some like terms together, some old algebra skills coming into play, and I'm going to subtract 68 from both sides. When I do that, I get that 2x is equal to 112. Think that's good. You'll let me know if it's wrong. And then I'm going to divide both sides by 2. And when I do that, I get that x is equal to 56. And so I found the value for x using vertical angles and using the fact that same side, no, they don't call them that, they're consecutive interior angles are supplementary. We use that to our advantage, and we got that the measure of angle x, or the measure of the value of x, is 56. Let's take a look at this guy. So we're going to find y if the measure of angle 3, still using this picture, so I need to scroll up a little bit. We're going to find y if the measure of angle 3 is 4y plus 30, and the measure of angle 7 is 7y plus 6. So the first thing I like to do is really just put that information right into my figure so that I can kind of visualize what information I have and what I'm looking for. So what I have is information about these two interior angles that are on opposite sides of the transversal. These are alternate interior angles. Alternate interior angles that are created by parallel lines cut by a transversal, those bad boys are equal. So I'm pretty excited because I know that this is going to be an algebra problem I can do. So I write that 4y, which is the measure of angle 3, is equal to 4y plus 30 is equal to 7y plus 6, given our picture and the relationship between alternate interior angles. So now I'm just going to solve this, subtracting both sides. I get that 3y, subtract 4y on both sides. I get 3y on my right subtract 6 over here, and 24 on my left, and divide both sides by 3, and I get that y is equal to 8. And so that's my final answer there. All right, so we have another theorem that we should keep in mind, and this theorem basically says if you've got parallel lines, so in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. I'm going to read that again. You got to be dealing with a plane, and you have a line that is perpendicular to one of two parallel lines, then it has to be perpendicular to another. So in this situation, we've got a line that is perpendicular to one of my parallel lines, then the thing that we can say is true is that it's also perpendicular to this other line. So this is another theorem. Now that we have this theorem, we can own this and we can use this in a proof. And I guess that's the end of it for us today. So I'm going to ask you to make sure you go through some of the information we talked about today, making sure you understand the relationship between angles, parallel lines, cut by transversal, what things are equal and what things are supplementary. And I look forward to talking to you soon. Let me know if there's anything I can do to help, and we'll see each other soon. Bye-bye.